We exist in a universe defined by a singular, haunting paradox. Light has no mass, yet it commands gravity. This is the architectural anomaly that keeps physicists awake at night. When you switch on a flashlight, you are not just illuminating the dark, you are bending the fabric of space-time. According to the strict laws of general relativity, gravity does not simply emanate from heavy, tangible matter like rocks or stars. It arises from energy density. And light, despite its ethereal nature, carries energy. Therefore, a beam of light has a gravitational pull. It is infinitesimally small, a ghost of a force, but it is real. This fundamental truth leads us down a rabbit hole to one of the most audacious concepts in theoretical physics, the Kugelblitz. The word is German for ball lightning, but in the lexicon of astrophysics, it represents something far more terrifying. It is a black hole constructed not from the corpse of a collapsed star, but formed entirely from radiation, a singularity made of pure, concentrated light. For over 60 years, the mathematics of general relativity suggested that if you could construct a Dyson sphere, a perfect cosmic mirror, and pump it full of high-intensity gamma rays, focusing them down to a single point smaller than a proton, the energy density would become so extreme that space-time would simply give up. It would puncture. An event horizon would form, locking that light inside forever. This was not merely a chalkboard fantasy, it was a scientifically valid solution to Einstein's field equations. A Kugelblitz would be indistinguishable from a standard black hole in terms of its gravitational effects, yet its origin would be cleaner, purer. For futurists and hard sci-fi writers, this was the holy grail of energy storage. A small Kugelblitz could theoretically act as the ultimate battery, radiating Hawking radiation at a precise, manageable rate to power starships or entire civilizations. We looked at the equations, and they seemed to offer a blueprint for godhood. We believed that if we could just engineer lasers powerful enough, we could punch a hole in reality whenever we chose. The beauty of the Kugelblitz lay in its simplicity. It stripped away the messy complications of baryonic matter, the neutrons, the crushing iron cores of dying suns, and left us with the raw relationship between energy and curvature. It was the purest expression of E equals mc squared. Energy acts like mass, therefore energy can collapse. We spent decades refining the models, calculating the temperatures, and dreaming of the engines we would build. We thought the only barrier to creating a Kugelblitz was our own technological infancy. We assumed the laws of physics were on our side, waiting for us to catch up. But we were looking at the universe through only one eye. We were staring through the lens of gravity, ignoring the chaotic, seething reality of the quantum realm that lurked underneath. And that realm has rules that do not bend, even for Einstein.
From that paradox of heavy light, we crash into a wall constructed by the quantum vacuum. While general relativity was giving us the green light to build our Kugelblitz, quantum electrodynamics, the theory governing light and matter interaction, was quietly preparing a veto. We recently discovered that the universe has a built-in circuit breaker, a fail-safe mechanism designed to prevent light from achieving the density required to break spacetime. The villain in our story of the impossible black hole is known as the Schwinger Effect. To understand why the Kugelblitz is dead, you must understand that empty space is a lie. The vacuum is not a void. It is a boiling ocean of virtual particles, pairs of electrons and positrons that snap into existence and annihilate each other in timescales too short to measure. Usually they're ghosts, mathematical placeholders. But when you concentrate light to the levels needed to create a black hole, you generate an electric field of apocalyptic intensity. This field becomes so strong that it literally grabs these virtual particles and rips them apart before they can recombine.
It drags them out of the quantum foam and makes them real. This is the dielectric breakdown of the vacuum. The energy you are pumping in to create gravity is instantly stolen by the vacuum to create matter. Instead of forming a silent, dark event horizon, your laser focus becomes a chaotic factory of matter and antimatter, exploding outward in a blinding flash of gamma rays and particle showers. The calculation is brutal and absolute. The Schwinger effect kicks in long before the energy density reaches the threshold for an event horizon. You are trying to fill a bucket that has a hole in the bottom, but the hole gets wider the faster you pour water in. The implications are staggering. This research suggests a hard upper limit to the energy density of the universe. Nature effectively forbids the concentration of electromagnetic energy beyond a specific point. It dissipates the charge, converting the currency of light into the currency of mass to lower the pressure. The Kugelblitz is not just an engineering challenge, it is physically forbidden. The universe will not allow us to punch holes in it with lasers. We have found the edge, where general relativity's smooth curves are shattered by quantum mechanics' jagged rules. We cannot build engines of pure black hole energy because the vacuum itself fights back, defending the stability of spacetime with a shield of exploding particles. We reached for the ultimate battery, and the laws of physics slapped our hand away.